Today I'm going to talk to you about rotations, what they are, as I think you can probably see already from my screen, and how to do them on a coordinate plane. A rotation, or you can call it a turn, is a transformation in which the figure is rotated about a point called the center of rotation. Now, when something rotates, it does not change its shape, it does not change its size, it just changes where it's pointing. When you're rotating something, you're turning it in a circle. So how many degrees is in a circle? 360. When you look at a coordinate plane, how many quadrants are there? 4. So take 360, divide it by 4, and each quadrant turn is a 90-degree turn. So if I were to just watch the tip of this triangle here, if I were to turn him 90 degrees, I would just basically be turning him like that, just into one quadrant. If instead I wanted to make him do 180 degrees, well, that's 2 sets of 90, so that's 1 and then 2. So we've got right about there is 180 degrees. And then finally 270 degrees is 1, 2, 3 turns. All right, now what direction did I just go? I just went clockwise. So this is important to know. Clockwise goes this direction. So obviously counterclockwise goes the opposite direction, like this. So if I wanted to go from where I am right now and do 90 degrees counterclockwise, I would just be turning him this way like this. Just as a reminder, 270 degrees clockwise. So basically I'd be here and I'd be going 1, 2, 3 quadrants. Well, that is the exact same thing as 90 degrees counterclockwise, just like that. And then the same thing, 270 degrees counterclockwise is the same thing as 90 degrees clockwise. Because of this, I'm only going to go over the rules for 180-degree turns and 90-degree turns, because then whatever I do for the 90, you can do for the 270 going the other direction. Okay, so we're going to start with this. Rotate the triangle 180 degrees clockwise. Well, I want you to think of drawing a line from each of those points through the origin to the other side. And a line is 180 degrees, so I'm looking for a straight line. When I make straight lines through the origin, they have to be the same length from their first letter to their new letter. So from A to A prime, they have to be the same distance from the origin. So let's go ahead and label these right here and draw a triangle. Voila. Now let's get rid of those lines so we just see the turn. All right, 180 degrees. Obviously, it does not look like a reflection. It definitely is a rotation. But let's look at these ordered pairs. We went from 2, 6 for my A to -2, -6. 6, 4 to -6, -4. And 2, 2 to -2, -2. What have you noticed? Well, hopefully you noticed that every X and every Y just changed to its opposite. Now, if you said it changed to its negative, we can't always do that because sometimes it starts in the negatives, but it changes to its opposite. So here is the algebra rule if you didn't want to write all the words, and that is my X and Y changed to -X, -Y, which again just means the opposite of the X and the opposite of the Y. So let's use this rule to rotate 180 degrees. Let's see, everything changes to its opposite. So -9 becomes a +9. 0 doesn't really have an opposite, it's just 0. B is going to be +4, -5. And C is going to be +6, +2. Remember, they're just changing to their opposites. Let's go ahead and plot those. So 0, 9 is here. That would be my A prime, my new one. 4, -5 is down here. And then 6, 2 is up here. All right, let's connect those points and see what we have. Ask yourself, does this make sense? If I were to draw lines from the B to the B and the C to the C, would they be straight lines that go through the origin? Well, let's see. Absolutely. So this is definitely a very good 180-degree clockwise rotation. Clockwise. Does it matter with 180 degrees if I go one direction or the other? And the answer is no. Clockwise and counterclockwise going to get you to the same shape for 180 degrees. When we're talking about 90 degrees, it does matter whether I say clockwise or counterclockwise. Now, 90 degrees. What I'm trying to do is I'm trying to draw a line from the A to the origin and then back out to the new quadrant and make a 90-degree angle. Now, first of all, before we do anything, let's talk about what makes sense. Clockwise is going this direction. 90 degrees is one quadrant. So this guy is going to turn. He's going to be somewhere in this quadrant. So here's the line that I was talking about. I made a line from the A to the new A. They are the exact same length lines, and they make a little 90-degree corner right here at the origin. And so my new A is what? It looks like it's a 6, -2. Now what I want you to do is we're starting to do this. I want you to start looking at the ordered pairs going, what's the pattern I see? All right, let's make the line from B to the new B. And again, I'm making this 90-degree angle at the origin. And the new B right here, it looks like it's 4, -6. Are you starting to see a pattern? Well, let's do the C. All right, we made a line from the C to the origin and then a 90-degree angle. And that looks like it is at 2, -2. All righty, let's draw that triangle. What do you notice about the numbers, the ordered pairs, when we went from here to here? Well, did you realize that the two numbers switched? Instead of having 2, 6, I have 6, 2. And yes, I know I have a -2, but I got to tell you, the way I think, I see 6, 2. And then I just remember that it's down here in this quadrant, which then would make that 2 a -2. But I don't think that way at the beginning. I'll show you in this real soon, this next screen. This one right here was 6, 4, so we flipped it to 4, 6. But because it was down in this quadrant, it was 4, -6. And then finally my 2, 2, well, that's easy, just switch them. But again, because I was down in this quadrant, it's going to be a 2, -2. So if you're good at memorizing little algebra rules, here it is for you. Basically, 90 degrees clockwise, you flip the X and the Y, and whatever the X used to be now becomes its opposite. I'm going to be completely honest with you. I do not memorize rotation rules. I do it where I flip the numbers in my head and I know where that point is going to go. For example, I know that point A, 90 degrees, is going to go this direction. Point B is going to be in this quadrant, and point C is actually going to be in this quadrant. And so we're doing that. I'm going to go ahead and erase those real fast. I'm going to walk you through my thinking. So point A is at -9, 0. I'm going to flip that, 0, 9. And since I know it's going to go 90 degrees, I know that 0, 9 is going to be right here. And this will be my new A. And then B is at 4, 5. I know it's -4, 5, but in my brain, I'm just looking at 4, 5. I'm going to flip those, 5, 4. And since I know it's going in quadrant 1, I'm going to find 5, 4 in quadrant 1. There it is. There's my B. And then finally, C is at 6, 2. Again, I know it's -6, -2, but I'm just doing 6, 2 in my head. Flip it, 2, 6. I know it's going in quadrant 2, so I'm going to find where X is 2 and Y is 6 in quadrant 2. Now all I have to do is connect my dots. There you go. I rotated it 90 degrees clockwise. This time, let's go the opposite direction, 90 degrees counterclockwise. So what direction is that? That's this direction. And because it's 90 degrees, it's just going to go into the next quadrant right beside it. To show you the movement, I'm going to again show you these lines that go from point A to the origin and then back out to the new A, making a 90-degree angle. And so the new A is going to be at, it looks like -6, 2. And again, just like the last time, I want you to start thinking about what is the pattern that you see. Here I've drawn my right angle lines from B to new B. And so the new B is at -4, 6, right here. And for my C, it looks like that one is at -2, 2. Let's draw that triangle. Okay. What do you see with the ordered pairs? What pattern did you see when we went from 2, 6 to -6, 2? and this one, and this one. And what I'm hoping that you see is we flip-flop the numbers again. Just like when we went 90 degrees clockwise, going 90 degrees counterclockwise, we're still flipping those two numbers into the opposite directions. All right, what is that algebra rule? So when going 90 degrees counterclockwise, the x and y flip places, and the original y changes to its opposite sign. Once again, I'm going to show you how I do it without using that rule, just how I think about these. Now this time, I know that this C, which is in quadrant 3, is going to go in quadrant 4. B is going to go in quadrant 3. And A is going to go from one axis to the other axis, and actually down here at the 9, but I'll show you that in just a sec. Let me erase these lines. Okay, here we go. Same thing. A is at -9, 0. I'm going to flip that 0, 9, but I know it's going counterclockwise, so I know it's actually here at the 0, -9. I'll do the C next. The C is actually going to go into quadrant 4 over here. He's at a 6, 2, so I'm going to do a 2, 6 here. That'll be the C. And then the B is at a 4, 5. And again, I know -4, 5, but I'm just looking at 4, 5. Flip that 5, 4, knowing that it's going to be in the third quadrant is going to be right here. And now all I have to do is connect my dots. There you go. So all I did was flip my numbers and know what quadrant they were going to be in to put the new dots there. So do it my way or memorize the rules. Here are the rules once again if you needed to write them down. All right, go have some fun.